Alrighty, folks. I think we're going to go ahead and get started. We're a few minutes past the hour. Of course, people will continue to trickle in, and that's no issue whatsoever, but we're going to get things going. Good morning, good afternoon, good early afternoon, good evening, wherever you're dialing in and joining us on this Zoom meeting from living rooms and from bedrooms and from nooks and crannies of your house you never knew could fit a desk. We're really glad that you're here to join us today. My name is Spenser Paul. I'm the Director of Sales for DoiT International. DoiT is actually Do It as opposed to DoiT or DoiT, as you might have noticed on the invitation. It's a strange capitalization. I can't claim responsibility for that. But the reason that we're here from the DoiT perspective is we are a CNCF organization ourselves. We employ a number of trainers and ambassadors, and our main function for customers or companies is to help them test, evaluate, and potentially migrate between different clouds. Along that journey, you might use a number of different tools, one of which we're here to discuss today, and it'll be in a lot more detail. So I'd love to welcome our presenter today, Eran Leib, the founder and VP of Product Management at Apolicy, and I'll pass it over to him in just a quick moment here. A few housekeeping items before we get started. As we know, no Zoom meeting ever starts on time and none finish on time usually either, but that's all good. We're gonna have a couple ways of making sure we can get you the information from this presentation afterward. During the webinar, however, you're not able to talk as an attendee. It's not because we don't want to hear from you. It's because we want to make sure this is organized in a way that's respectful to all. So there's a Q&A box in the bottom of your screen. If you're not used to using Zoom, it's just going to be on the bottom of that screen as you hover over the video. And you can feel free to drop your questions in there, and we'll get to as many as we can at the end. Yes, I mean, we will have time dedicated to Q&A at the end, and my function apart from the introduction is to make sure I'm monitoring that queue, so keep the questions coming. This is an official webinar of the CNCF, and as such is subject to the CNCF Code of Conduct. Please do not add anything to the chat or questions that would be in violation of that Code of Conduct. In short, be respectful of all of your fellow participants and presenters. Please note that the recording and the slides will be posted later today to the CNCF webinar page, which you all have the link to as well. So don't worry, if you missed any of the beginning or the middle or the end, this will all be recorded for posterity. And with that, I'll hand it over to Eran to kick off today's presentation.
Thank you, Spenser. Hello again, everyone. It's a pleasure to be here today. My name is Eran Leib, and I'm here to speak about Kubernetes policies. Just FYI, no prior knowledge is required to attend this webinar. I'm going to try in the brief time that we have to educate you to the best that I can about the subject. Let's see what's on our agenda today. First, we'll start with some terminology, so we all speak the same language. Second, we'll double click on the way Kubernetes enforces policies in the cluster, mainly admission controllers. Third, we'll see if what we get is what we need and is it enough. And lastly, some thoughts and ideas going forward. So heads up, this is my first ever CNCF webinar. So you're in my premiere. However, it's not my first webinar ever. I'm one of the founders and VP Product Management at Apolicy, as Spenser mentioned. And we're a Kubernetes policy orchestration solution. Before that, I co-founded Whitebox Security, where we built an amazing data access governance solution. Whitebox Security was acquired in 2015 by SailPoint Technologies. I started my journey about 20 years ago as a system programmer. Today, you would probably call me a DevOps. My interests throughout my journey were focused mainly around cybersecurity in general, and more specifically around identity, access, and policies. You might even change that DevOps that we talked about to DevSecOps. And yes, among my personal interests is Lego, and I really hope my wife isn't listening right now because she would probably try to look at our Amazon account and see what did I order lately. So without further ado, let's get going. So cloud native changed and still changes the world. It gave everyone the freedom to work faster, release faster, and be more efficient. And there's nothing we all love more than efficiency. It's very simple to start with, though it gets very complex very fast, and it doesn't go unnoticed. I would change the new stack quote here from likely to become an all-out chaos to is an all-out chaos. So let's focus on Kubernetes. It's probably one of the most notable cloud-native projects, if not the most notable one. And also this webinar is about Kubernetes policies, so we should. Containerized workloads without orchestration becomes chaotic at scale. Working with Kubernetes is easy. Just define your workloads, your desired state, and Kubernetes will take care of the rest. Kubernetes will schedule your workloads for execution, will reschedule them, move them around when changes occur, and make sure everything is aligned according to your desired state configuration. For some of us that installed application clusters in the past, that may seem like magic. Dynamic, automated, ephemeral, that's the name of the game here. And that dynamic part is what makes it very, very complex to at scale. So these charts actually speak for themselves. Containers are ephemeral by design. They are even more ephemeral when they're orchestrated. Their churn increases due to the automation. There's also proliferation of workloads with the introduction of microservices and serverless technologies. Today, we tend to break apps to smaller components, and in turn, that increases the ephemeral factor. With automation in place, we can add more clusters, making it more interesting and also more complex. It's all good. We just need some order, because what do you get from chaos plus chaos powered by chaos? All out chaos. So let's see what Kubernetes has to offer to bring order to this chaos. To get everyone on the same page, I'll explain some Kubernetes basics, and it's going to be very short. So Kubernetes has many knobs and levers baked into the cluster control plane. They control the various behaviors of the cluster. Most of the time, they have a very specific destination. Those control, by the way, might implicitly influence other behavior and not specifically the one that they were only designed to address. And that adds more complexity. It's not always evident, even to the expert users, how all of these play together, and they can't even see the big picture. The flow here is very simple. All access to the configuration database, that's the etcd, goes through the API server. The Kube controller manager uses controllers with continuous loops, infinite loops if you may, checking the current active configurations versus the desired state. It then tries to make the changes to get us where we want to. So what's missing here? Seems like utopia, right? So can everyone just ask whatever they want? Can the controller choose whichever strategy it wants to use to get us to that point? That's why we have those policies. I'm gonna talk just for a second about policies versus configurations. I often hear people confused about these two, especially in Kubernetes, and use them interchangeably. So I thought it's a good idea to make sure that we're all on the same page when it comes to these two in Kubernetes. Configurations define the desired state, the desired behavior and desired state parameters for a specific object. For example, replicas equals 4 for a deployment will make sure that you get 4 replicas for that deployment, or volumes to attach. Capabilities parameters like running a privilege workload or sharing the host network. And of course, labels. It's very important in Kubernetes to include labels. Policies, on the other hand, define the behavior for other objects, often called guardrails. They define the wiggle room for configuration, some of them in a dynamic fashion and some less dynamic. It's also important to understand that guardrails are not the actual configurations. So policies help us to control what we allow to use inside our cluster. To quickly summarize, Kubernetes is a declarative infrastructure, also known as desired state. The desired state is defined inside the various component configuration, and it tries to satisfy them. The controllers are the one driving the change according to the policies in place. Essentially, the controllers enforce your policies in Kubernetes. So our main focus today is going to be policies for admission controllers. Every change before persisted to the etcd will go through the relevant admission controller. If it's not enabled, it will be persisted immediately. If a specific admission controller will be enabled, it will check your guardrails, the policies, and they will verify if the change is allowed and persist the change, or deny it if the change is not allowed and keep the configuration unchanged. That's important because other controllers are trying to achieve the desired state for you. They're using that persisted configuration. We want to make sure that any change complies with our policies. These controllers are serial and they're also ordered. So each of them runs, passes, or rejects the request according to the policy, to each of their own policy, and pass it to the next controller in line. There are basically 3 stages we would examine today and their respective policies: mutating admission controllers, objects schema validations, and the validating admission controllers. We're not going to discuss them necessarily in this order, but this is the order of execution. First mutating, then the validation, and then the webhook validations. So the first one I wanted to discuss is the image policy webhook. Images are, of course, a centerpiece in your cluster. Which images are acceptable, which repositories are okay to use, and many other aspects. The image webhooks allows coding your corporate policies related to the images and repositories and whatever you want. The webhook would get all the requests related to all pods. It does not distinguish between different pods. Each request will include all images in the pod with annotations from the pod. You can think of the annotations as tags or labels that you attach to the objects in the cluster. They're kind of like labels, but you cannot use them to do different things that you are allowed to use labels for. The webhook can either allow or deny the request. Denial of the request will cause the pod creation to fail. It's a good idea to add reason to your decision because otherwise you'll get lost. As you can imagine, if all pod create and modify goes through the webhook, it is important to make sure it is always available. If the webhook is not available, nothing would run on your cluster because everything would just fail. Which brings us to the last challenge, default deny versus default allow. You can avoid the nothing would run on your cluster using the default allow. However, that's the eternal struggle between security and operations. We want to keep things secure and not necessarily only allow everything in. So here's a short example of the image review. On the top snippet, we see the request. There are 2 containers in the pod. We see both images for them. We can also see that there is an annotation which says break glass. That's the value of the annotation. And we can see that the namespace is over there. It's called my namespace. Basically, that's the context that you need to take a decision. Below, we see the decision, which says allowed false, and the reason which says image currently blacklisted. Very simple, right? It's no rocket science here. Just write your code in the backend. So I wouldn't say it's that simple because I have some expectations and I can't say that this webhook meets them as is. So first, I would expect Kubernetes to support some basic use cases. For example, create and allow list of repos without writing code. Just type in your list. Second, as I mentioned before, this kind of webhook just might enhance the ongoing tension between security and ops. Third, I think that there is some context that is missing here. For example, labels can be very useful here, not only the annotation. And last but not least, there should be some basic filtering without code. For example, I don't want some specific namespaces to be going through this webhook, using labels, using namespaces, using any kind of selection that you wanted. This webhook capability can also be achieved using the validating admission controller. We'll talk about that controller in a few slides. Our next subject is resources. We always need more of these, right? We need to keep in mind that a cluster, in most cases, is a shared economy. Think about WeWork. We need to distribute the resources according to the organization's need. In this case, Kubernetes has two policies, a top-down one and a bottom-up. The first, resource quota, defines the quota per namespace from the cluster level. The second one, limit ranger, defines the rules for dividing the quota between the workloads inside the specific namespace. The resource quota is, of course, an admission controller, because that's what we're talking about here. To enforce it, you must have a quota object defined in every namespace. The pitfall here is that if you leave a namespace without a quota, it's unlimited. The default policy is unlimited. There are, of course, some rules and regulations. Unfortunately, there's enough rope here to hang yourself. If your sum of defined resource quotas is more than what the cluster has, there will be contention. First come, first served. Defining resource quotas requires that all pods have limits defined. If you don't have limits defined on a workload, it will fail and not be created. A workaround for that would be using the limit ranger, which defines default values for the limit of the workloads inside the namespace. This quota policy allows defining many quotas on many different resources, including how many objects of each type are allowed. Specifically on the last point, I would suggest use what you need. Don't overconfigure. Don't put limits if you don't actually need one. So let's talk about the limit ranger. The limit ranger is focused mainly on the CPU and the memory for individual workloads inside the namespace. Same rule as resource quotas. If you didn't define any, it's defaulting to unlimited. Generally speaking, it is always important to make sure that when you decide to define a policy, make sure that you cover all your bases. As expected, there's enough rope here as well. If you allow too much, your pods would run into contention. Contention would cause pods creation failure, which is not fun. To summarize, resources and limits. Unlimited leads to contention. Contention leads to failure, and failure leads to, well, you know where that leads to, right? Our next subject are the pod security policies. And there's an important disclaimer here before discussing it. It is, like many other features in Kubernetes, a beta feature. There are rumors of its death before arriving to GA. They are probably true. I suggest you go to SIGAuth and take a look at the discussions over there. However, a replacement solution was not yet chosen. There are some candidates, but it's not specifically designed yet. Now let's dive into this. PSP, or Pod Security Policies, defines the guardrails for workloads. There are about 20 configurations it controls. PSP, unlike resource quota and limit ranger, is a cluster level object, so it's not defined in each of the namespaces. You can define as many PSPs as you want or need, and we'll see why that's actually needed. Each PSP is a permutation of the managed configurations. Those permutations are profiles of the guardrail. So if, for example, I want to create one profile, I will create a permutation of the PSP and give it a name. And then if I want another profile, I'll create another one and give it a different name. So here's the tricky part. You need to allow your service accounts to read the profile for them to apply it. So they kind of need to want to apply it. It's kind of weird. And to make this really fun, if you define the loophole in one profile that allows workloads in, and that workload applies that profile on it, they will go through that loophole. I want to explain this point more thoroughly because people get confused about that. Let's say that I have 5 different profiles. Each of them defines a different permutation of PSP. When I allow a workload to use a profile, and we'll see that definition later on, through a role binding, it essentially applies that profile on the workload. Having multiple profiles enforced on the same workload gives freedom of choice, which is not really required, to the workload. The workload will try to match the configuration it currently has and pass through a profile. The first one it is able to go through without changes to the workload configuration is the one that it will go through. And it's also, by the way, alphabetically ordered. As a best practice, it is better implementation to make sure every workload matches just one profile, which is the one we wanted to apply. Otherwise, you gave it a choice, and what's the point? That, of course, requires much more planning and more objects, role binding per namespace, and specific roles, etc. To make this actually work, better not use the default service account. If you do use the default service account, you would probably assign too many profiles available to the default service account, because the user, the service account of the workload is the one that needs to be able to use the profile. So if you use default in too many places, many different profiles would be assigned to it, and it could choose, quote unquote. So that's going to beat your goal. Recently, the Kubernetes team released 3 standard profiles. The release came with a disclaimer that policies in this space needs to be defined on a case-by-case basis. So one size does not fit all. It actually doesn't even fit most. Meaning these profiles are a starting point. You have work to do. I would argue that over-profiling is bad practice. It beats the purpose because it's harder to manage and keep under control. The bottom line here is balance. Keep your balance here. Even though there are about 20 configurations, keep in mind that some of them are not flags, meaning that they're not a true-false thing, and they can have multiple values and sub-configuration, for example, volumes. So what's covered? Workload and pod isolation parameters, such as denying sharing host network, host process ID, etc. Those configurations are important because they can result in pod breakouts. Security context for the container, for example, the user running the container, allowed Linux capabilities, and also the default values for the users and groups running the container coming from the pod downstream to the containers. Those are important to define the actual privileges of the container, of the privileges inside the container that is running. Also, storage-related configurations, for example, allowed volume types, access to the container root file system, which is also kind of a problem, and accessor mode for the mount points. Too much wiggle room for the containers could result again in breakout and access to undesired information. Finally, what's on everyone's agenda, the privilege mode and escalations, which guards from workloads that can spawn other workloads in privilege mode or run themselves in privilege mode. Just a reminder, this is a policy of allowed and denied configuration. It is by no means setting or changing the configuration of any workload. Last point to remember, many of us look to CIS benchmark for guidance. There's a whole section, section 5.2 in the latest CIS benchmark for Kubernetes, that's version 1.5.1, discussing pod security policies. It does not prescribe you use PSPs. It does, however, require setting PSP-like controls to enforce policies for pod security. So this is the privileged profile example from the Kubernetes website. As you can see, you can basically admit any workload with any configuration. Most of these stuff is run as any, run as any, run as any, or just asterisk. It's actually a good idea to have that profile to make sure that there is a way out in emergency cases, and also for the Kubernetes, the kube system workloads to be able to go in. This is the restricted example, and it's not the whole file, but just part of it. We can immediately see quite a few false flags denying configuration. Well, it's restricted, right? This configuration might fail quite a few workloads. However, if your workload can work with this policy, you better use it, as it minimizes your attack surface originating from the workload. There's also a baseline profile, which is the middle way between those two. The biggest issue, other than it might be deprecated in about a year, when it comes to PSPs, in my opinion, is that it's too rigid from a configuration and also implementation view, and maybe even management. Every permutation is a new profile, new role, and role binding. Otherwise, if you permit them all in one role, you might get the wrong result. For example, allowing a workload you wanted to stop. It's quite complex to debug PSPs and finding the root cause for something that was blocked. This policy type manages too many attributes and was not built actually to do so from the ground up, because I don't think that it was built for the amount of variations that exist. However, having said all that, it is possible to use it. You should care for the configuration that PSP looks after, but you need to carefully plan on how to do it. Let's talk about labels. I love labels. They make everything in Kubernetes so much easier. It's such an important mechanism that is used all around. It helps in node selection, it helps service for workloads matching, and many more places. You can also think about it the same way you think about annotation, just actually usable in some aspects. So let's talk about the labeling policy in Kubernetes. There isn't one. Yep, it just doesn't exist. If you wanted to make sure, for example, that all workloads have a label saying who is the owner or which app they are part of, or anything for that matter that you actually wanted to label your workload with and make sure that it is over there, you have to actually write code for that. We'll get back to that soon. That's a big shortcoming that I would expect Kubernetes to handle. So now we're going into the really interesting parts. So this is somewhat of a different beast. It's not using a policy to make sure folks in the cluster play by your rules. It is there to provide you with the power to make sure that if they don't, you will straighten them out. So mutating admission controllers are the first to be evaluated. They are based on your code, and you can have multiple mutating admission controllers. Each of them gets the request, it inspects it, mutates it if it needs to, and moves it to the second in line, trickles down the line. The order of evaluation here is very important because downstream admission controllers will get the request that might have already been mutated as their input. They will have to know how to deal with it, and they will not know how the original request came in. Sometimes knowing the original request can actually be a valuable information. It is pretty handy that you can inspect a request for any type of object. So unlike the image webhooks, you will get any request type, not only for workloads. For example, service accounts or ingress creation or modifications or services and roles, whatever you want can come into this. This, of course, opens up many more opportunities and allows you to create a much more complex policy. Lastly, the whole request goes as input. It means that you get a complete context, very useful when making policy decisions. It's very useful to know the complete context. A good use of those mutating admission controllers can be to automatically label workloads. It's not as simple as it sounds, though. Assuming you have access to metadata, which is supposed to be added as label, you could definitely do it here. A word of advice, if you decide using this capability of mutating admission controllers, best practice dictates you should only set unset values rather than change existing values that you get already inside the request, because that can cause a lot of problems to the downstream admission controllers. So the last type of admission controller to run are the validating webhooks, basically the last keepers of peace and configuration. Unlike the mutating controllers, these validating all run in parallel. If one of them fails the request will fail completely. It will still allow the other admissions to complete, so you would know if there are other issues you need to attend to. the possibilities here are endless. Anything enforceable in PSPs, image policies, label existence, anything can be enforced here. And also, much like the mutating admission controllers, it opens pretty much the floodgates because you can validate objects other than workloads. Enforcing naming convention for various objects, minimum required configuration, label existence, again, anything here is possible. The only caveat is that you have to write it yourself and make sure it works and make sure it documents the decision well. So they're traceable and understandable. These webhooks, what's used to be called in the history of in mainframe time, it would be called an exit, is basically write your own code, do whatever you want, just play by the basic rules and return the expected codes. With great power comes great responsibility. This seems like, if you see this for the first time, it seems like the answer for many issues we've discussed here, and yet your policy is still inside your code. So everything is hard-coded. So how does it look like? Every request to the validating controller brings in all the data wrapped within the admission review object. You can see the kind on the left side, which says kind admission review. Mutating, validating, and image webhooks require you to first register the webhooks with the cluster. For mutating and validating, you can define actions and resources paired together for different webhooks. So for example, you can say for create and modify of service accounts, I want to go to a specific webhook, and for create and modify for roles, I want to go for another one, and for workloads for a third one. You should also note that get is not a verb that you can use. It's not an action that would go through the admission controller. On the right-hand side, we can see the response from the webhook, which allows you to add messages. So for example, you can see that allowed is false, and you can see that the message is you cannot do this because something. There are some additional notable admission controllers that control very specific aspects. For example, always pull images. Even though the name speaks for itself, the complete behavior is not so evident. This admission controllers would modify every new pod to force pulling images from the image repo. Basically, it means that if you turn it on, you set a policy saying that all pods must always pull images. Simple, to the point. It's very simple. So the reason behind it is to avoid the possibility of someone using the image that you already pulled into a node, even if it's not authorized, just because it exists on the node where his or hers workload is running. You can probably achieve this very similar functionality with the mutating admission controller and be more selective. So this actually might contradict the recommendation to refrain from modifying set values. So just think about which one is better to use. Default storage class is also pretty straightforward. It will assign a default storage class for any persistent volume claim that is missing the storage class type. This way we can make sure that special storage classes that are probably more expensive are not assigned by default and must be requested specifically. The next one here is the event rate limit. It's actually a very useful admission controller focused on specific subject with fairly clear policy. The previous one that we talked about, each of them the policy is just defined by saying, yes, no, or defining the config file for the default storage policy. The event rate limit is also very similar. It has a config file for itself. So the API server is important, as you can imagine, and we don't want it to be flooded with requests. So the configuration file for this admission controller defines buckets for queries to the API server. It uses various levels like server, namespace, a specific user, and also source plus object. Probably it's very useful to define it to make sure that your API servers are not flooded. And probably one of the most useful is the pod node selector. That helps us to define which pod is going to be scheduled on which node. Here again, for example, if you wanted to make sure that PCI workloads can only run on PCI approved nodes, that's the controller that can probably help you to do that. So to recap, admission controllers are the mechanism that Kubernetes uses to enforce many different policies. But, and there's a big but here, policies are managed all around. It's complex to understand the big picture and what's the actual effective policy. Even for simpler policies like pod not selector, there would be a configuration file per namespace. So it's not so simple or evident to see the big picture. Advancing to multi-clusters and multi-cloud complicates the situation even more. So I thought it's a good idea to give you some homework now that schools are closed and no one knows if they ever reopen, at least not here in California. So I suggest that you start by some simple checks. List your active admission controllers, see what's running. If you're running in a cloud provider, there might be some variations in the commands that are here to understand what's running. Second, if you use the default namespace, stop. Start namespacing. It's super helpful and helps you to actually bring some order very quickly. Even if you just start now and you don't have many projects or applications, better start with namespacing now. It will be harder to do it later. You can thank me later. Third, the default service account. If you don't define a service account, or if you define default, see if you can switch to a named account. Using the default service account makes your workload access to the API server unaccounted for. It is also important for the proper usage of PSP. Last, and again, this is comes with a grain of salt, this recommendation, cautiously enable the PSP using the predefined profiles from the Kubernetes website. Even if you plan later on moving to another enforcement method, it can be a good idea to know where you are and lock down at least some of the usual suspects. So I'm going to really quickly move to a really short demo just to demonstrate some of the things that we discussed here today. So I have a local cluster here, and the first thing I want to show you is the resource quotas. So here we have the compute resources, configuration file for a namespace, and the object counts that I defined here. I'm going to apply to a specific namespace that I created before. And I'm also going to apply the So now that I have this in place, I'm actually going to create a namespace here, a workload here, sorry. And we can see that, let's get the quota for we can actually see the compute resources and objects quota in my environment. Just a second. Oh, sorry, I made a mistake here. Okay. It's going to create it, and we can see that now I'm using one of the pods, and that's the limit. So if I'll try now to scale it up, it's trying to scale it up. We can see that it's not going to allow it. So if I'll just do now kubectl get deployment minus n limit address, we can see that it's trying, that it's configured for 2 and it just have 1 available. So that's the first part. So just remember that if you define a resource quota and you already have something in place, it's not going to enforce it and scale down your resources. Only if they scale down and then try to scale up, it won't be able to do so. The second thing that I wanted to show you is actually the how we deny privileged workloads from running. I'm not going to do this using pod security policy. I'm just going to show you how to do it using the open policy agent as an admission controller. And we'll talk about the open policy agent in a second. So let's go in here. This workload that I tried to create here is privileged. So technically, you will see here that there is a privilege true. And what I'm going to do now is actually to create a rule here. I created the rule beforehand, so you can see it here. And you can see that it's actually saying that a privileged workload should be, sorry, wrong folder. So here it is. And what I'm going to do now is I'm actually going to try and create this workload, another one, just the inventory, which is also a privileged workload. I'm going to try and create it. So if we go into here and we do kubectl apply, so we can see that it cannot run the inventory mentioned because it's a privileged workload, and it cannot run the inventory update since it's a privileged workload. So it's basically denying both of them from running. Now let's say that I wanted to only do it for production workloads. Then I'm actually going, if I was using pod security policies, I would start needing to create new profiles and start labeling them differently and doing a lot of changes. In here, what all that I need to do is just to change the code in here, and I'm going to make sure that this happens. So now, if I'll try to create it, it's actually going to be able to create it. Sorry, I didn't update the workload just yet. So I'm going to delete the rule and reload it. And now I'm going to recreate it using this enhanced rule, so to speak. So technically, if I'll try now to create it. Should allow me to go in. Oh, sorry, it's with the environment of production, so it's not supposed to let me in, but if I'll put this in comment, it will allow me to go in. So to summarize, this allows me to make a much more dynamic policy without starting to change a lot of code in. Let's go back to the slides. So after everything we've learned here, it's all awesome and no open challenges, right? Not exactly. As you've seen, let's focus the discussion on some very specific issues that are easily identified. We need to decouple policies from admission controllers code, because otherwise, if I try to do what I just did with PSPs, it would be hell. Running in a ephemeral environment means everything is dynamic, including our policies, and we cannot change code every time our policy change, and they will change. Adding more clusters using different providers is a forcing function to centrally manage and orchestrate our policies. And last but not least, the old practice of maintaining a different policy for dev, task, QA, and prod is, well, old. If we wanted to shift left, and we do want to shift left, we have to make sure we are consistent. So the first step here, it must involve policy as code. We've seen many, something as code, predominantly infrastructure as code in the last few years, especially in the cloud native world. The open policy agent that I just demonstrated, like a small part of it, is a good first step in the right direction. It allows decoupling code from policy, and it uses declarative language, which works well in tandem with Kubernetes declarative infrastructure. OPA Gatekeeper is a project using the open policy agent that created a simple way to employ webhooks using policy as code. It has libraries of policies which you can use as is or modify as needed. I would be amiss if I made you think that admission controllers and their policies are the silver bullet you are searching for securing your Kubernetes. They are just one piece of a much bigger picture. Admissions are the last enforcement point in a process that you must start as early as possible in your dev pipe. It's absolutely necessary to enforce this as left as possible in the process to be able to close the loop successfully and resolve workloads issues. The admission are actually gatekeeper. They don't help you remediate issues. They help you make sure that once you remediate, those issues don't pop back up like an uninvited guest. So at Apolicy, we look at policies as part of a broader process that includes risk analysis and remediation. We actually start with risk because we want to help our customers understand what is the current risk posture of their clusters and where they are most vulnerable. We use this information to guide our customers and help them build the most appropriate policies for their clusters and workloads, but we don't stop there. When you know where you are, hence risk, and where you want to go to, hence policies, we help you drive your clusters towards this desired state by automating the remediation effort. So it's not just, here's the list of problems and good luck, or here are some policies, now what? It's about understanding where we are, what are the most important issues, and how do we get to the best possible posture for each and every one of our workloads. Once we started looking at risk, policy, and remediation as a whole, and had more and more discussions with organizations about this concept, we've learned that different organizations are often in different situations or maturity levels. So we've built this maturity model to help organizations identify where they are and where they would like to be in the future. We do think we don't think it's everything or nothing. We think it's wherever you are, you can get better. What we are working on at Apolicy is a solution to help organizations quickly and easily transform their risk, policy, and remediation processes. I really hope you've enjoyed today's session, and I thank you for taking the time to learn about Kubernetes policies, which is the topic that is very close to my heart and also my work at Apolicy. I would recommend thinking about policies in context of risk, compliance, and best practices, while remembering that eventually policy is part of a broader process. Don't want to forget that we're also hiring at Apolicy, so just hop on our website and feel free. And a word from our sponsors again about KubeCon. And at this point, I'm happy to answer any question you might have.
Perfect. And thanks, Eran, for the great presentation. There's a lot of information there, so thanks for packaging it together for us really well. As a reminder, we've got an open Q&A in this Zoom meeting, so if you have any questions that popped up during the presentation, please feel free to drop them in there. I'll start with the question we do have added, which there was a specific person who's asking, is it possible, Eran, for you to share the code, those YAML files you're using for the demo? Is that something you're able to share? I'm not sure the,
yeah.
Okay, cool.
Yeah, I can share it. I just don't know how it will be delivered because I know how to deliver the presentation, but we can ask our CNCF host to share it as well.
Sounds great. And as a reminder to those who might have joined a little late, don't worry, we've got this whole session recorded. The content will be posted on the CNCF website later today. So there will be, posterity's sake, some continuity from what we discussed. Anyone else have any questions? Now's the time to throw them into the Q&A. I don't see them at the moment, but Christy, let me know if you see something different.
Looking good.
Yeah, a couple of compliments coming in. We appreciate that as always. Even if your comments aren't questions, we appreciate it a lot. There was a specific question, can the discount for CKAD be applied before KubeCon? That's one I don't know.
Yeah, I can follow up with the person who asked that question separately. This is Christy from CNCF team, so I'll follow up with you separately on that.
Sounds good. And another question we just got. For a greenfield project, what is the best way to start adopting policies, Eran?
Oh, that's a great question. So for a greenfield project, I would say that the best way to start adopting the policies would be to start them to the left as much as you can. So start by educating the developers and enforcing policies already over there at the CI and CD processes, making sure that they don't do and don't use bad practices. For example, like default service accounts or using privileged workloads if they don't really have to.
Great. Another question just came in. Looks like there's a question. Are you recommending for Istio? Is Istio a tool that you've seen a lot of action with, Eran? Any thoughts on that?
No comment.
Yeah, I know we always have a lot of.
There are different solutions that can be used, but service mesh in general is probably a good idea.
Cool. Any other questions in the Q&A? I'm not seeing any others come in, but please, we've still got a few minutes if anyone wants to get any further ones in.
Yes, Spence, it looked like there was someone, Andreas, had something in the comments of why is there a discussion about removing PSP von Kubernetes?
So I'm not on SIGAuth, but from what I've seen and also discussed with other people, it's kind of because of bureaucracy in a way. So there was, because it was mainly, they wanted to no more beta forever. So PSP has been in as a beta feature for a very, very long time. And at some point, it's they decided no more beta forever. So it kind of got, like a grace period for now 3 releases forward, which is about 9 to 12 months. And it will be either changed with, I don't know, a V2, or maybe they would adopt Gatekeeper, which is another option that might replace the PSPs. Again, one of the reasons that PSP is used, but it's kind of hard to use it because of all the limitations and management issues around it.
Cool. And we had a follow-up on the Istio question. You said no comment. What do you mean no comment?
No comment, just because I don't have enough information. And are you recommending Istio is a very general question. Recommending it in what context? It needs to be a very, very specific question, and and to learn the project and see if it makes sense. It doesn't fit everything. It's not your magic silver bullet, that you can just use and it will solve anything. It's like people thought admission controllers are a silver bullet. They're not. Kubernetes as well. I heard Kelsey Hightower speak a couple of weeks ago. I heard him say, people thought that they would throw Kubernetes in and it will solve all their issues. It's not. It's not a solution. It's just part of a bigger scheme, and you need to look at everything around and see if it makes sense to use it.
Great. Another attendee asked, you did not talk about network policies. Is this something different of our daily subject?
So network policies is somewhat of a different beast, and it's I think it's a whole webinar of its own. That's why I didn't discuss it. So that's mainly the reason.
Right on.
And I see that there's a follow-up question on the Istio. So for workload segmentation, yes, it might be a good idea to use Istio for workload segmentation. Again, we need to look at the specific project and specific scenario to see if it makes sense or not.
All right, it looks like we're just past the top of the hour. Any final questions from any of the folks attending? Christy, Eran, anything else from your side?
All good.
All right.
Go to KubeCon.
Yes, indeed. That's the takeaway as well. But thank you all so much for joining today. I saw, I think, more than 100 folks on the line. So thank you very much for taking your time out of your busy day to join us. Again, the webinar recording and the slides will be online later today. So we look forward to seeing you at future CNCF webinars, and have a fantastic day, everyone.
Awesome. Thank you very much, Spencer.
Thank you, Eran.